Are you sick and tired of sifting through complex medical text and jargon? Well, meet Agent MedGemma. This is a AI-powered health coach that helps empower people to understand a bit more about their own health and gives you information in a quick and accessible way. So this is an agentic LLM application that uses Google's MedGemma on the backend, and is a end-to-end project that I've built for the Hugging Face MCP and Agents competition hackathon over the last weekend. So before we give it a whirl, I'm gonna jump into the technical stack of it, and then we'll show you a bit of the backend, and then we can give it a test. All right. So this is how the stack is set up. So earlier you saw the interface, which is a Gradio instance hosted on Hugging Face spaces. It's a quite nice and tight space to host quickly, and also Gradio gives you a very quick way to build up a GUI and chat interface. Really slick stuff. And on my backend, I'm using this service called Model. So Model is a nice serverless cloud space for people who want to build, or researchers to quickly host up LLMs, for example, and not worry too much about the ops behind the scenes. So you can write everything really in Python. It's really quick. Here I've used a multi-container system in Model, where the first container here is connected up to the Hugging Face transfer. So that gives you really quick, super fast download speeds for large models. The MedGemma for billion parameters model, so that's about 2 gigs. Hook that up to small agents from Hugging Face as well. And MedGemma is going to have a tool which is Wikipedia. You can call out Wikipedia if it's unsure of what to respond or needs more information. So this is all running on a T4 GPU from Model, so it's really quick, and they give some awesome credits for the hackathon, so thanks for that. So I'm using a VLLM engine to kind of do the inferencing for MedGemma, and then I'll show you kind of the backend later why we're using it. But essentially it gives you really quick inference times and quite optimized for that. Once all that's been churned, we'll expose it to the user via a fast API endpoint here, and that goes back to the user. Right, so let's hop into Model. See, here we are. So this is what it looks like. Let me close that. So this is what it kind of looks like on the back end. We have Model and have like the multi containers here. So initially you have this download model container, which goes into a fast API endpoint, and that will come up into here where MedGemma is hosted. A live GPU running for the evaluation process, so you can go and test it out. Got some credits here included, and here we have an example of what it looks like in the back end. So you can see, I'm just going to show quickly here what VLLM does. It does quite a lot of smart optimization for the inference, setting up a KV cache here, and loading the model, putting up graphs and stuff like that. So here I'm using the 4-bit MedGemma model by Unsloth. So it's a quantized model and runs a bit faster, takes up a bit less memory. And I think because most LLM are memory bound anyway, they give you quite nice sort of metrics on what container is doing, how much GPU has been used. Here I've just made a test run earlier, and it's showing the utilization. So here you can see that what I mean by memory bound is doesn't matter too much on the compute, but you want quite a fast memory or video RAM bandwidth for your LLMs to run quickly on the backend. So here I've run through a example earlier, and this is what is coming up on the backend. So it takes a couple of seconds, about 7-8 seconds, to fully run a request, which is pretty fair. Okay, so we're gonna hop back to MedGemma and give it a whirl. So I've set up a few easy examples where you can just click it and it will run on its own. You feel free to test it out on your own. What are the most common examples are symptoms of a stroke, and that will go off to the model now. So here I'm using an async kind of streaming-ish feedback loop where I can see what the model is doing behind the scenes. And here we go. Most common would be numbness, difficulty speaking, understanding, blah, 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 blah. So that all sounds pretty accurate. I quite like MedGemma for this use case because it already has a pretty good understanding of medical text, and it's really good with the language side, putting words into like simpler kind of text for people to understand. I think it's all great. So what could come next? So it is a multi-modal LLM, and technically you can take in medical images as well. But that needs a bit of restructuring on the code side on the backend. What I want to do is probably run it through a couple rounds of evals to really check. What I want to do is kind of run through and see, over a broad range of conditions, how well it can perform in terms of this kind of de-jargonization or making things simple. And yeah, this is an end-to-end agentic AI application that's built up with a front end and the back end and some optimizations put in. I'd love to make a bit more updates here and continue working on this outside of the hackathon to have a bit more insights and use from this model for my own case. Yeah, there we have it. Agent MedGemma for the Hugging Face MCP and Agents Hackathon. All right, peace out.